Move in, now move out, hands up or hands down, back up, tell me what you gonna do now. Move in, now move out, hands up or hands down, back up, tell me what you gonna do now. Keep rolling.
Rolling is pretty central to life. It's really how most of us get around. But some of the things about rolling can be a bit non-intuitive. For example, what determines how fast things roll? Having some races will show us what is important and what isn't. So here I have my incredibly complicated experimental apparatus, a ramp, and 4 objects. First one is a solid metal cylinder, solid plastic cylinder, a smaller metal cylinder, and the last one is a hollow cylinder or a pipe. So, our first race will be between the large metal cylinder and the plastic one to see if weight or mass is important. 3, 2, 1. So it turns out they're exactly the same. So what that tells us is that the rolling speed doesn't depend on the mass of the object that's rolling. The next race will be between large and small to see if size makes a difference. 3, 2, 1. Again, a draw. So we know that the rolling speed doesn't depend on the radius. So it doesn't depend on the mass and it doesn't depend on the radius. So when I do the race with this pipe, it doesn't matter that these are different sizes, because we've already shown that the radius doesn't matter. And it doesn't matter that they're different masses, because we've shown the mass doesn't matter. So now if I race these two, three, 2, 1. There's a clear winner in the metal cylinder. And the reason behind this is because they have a different moment of inertia. And moment of inertia is a measure of how hard it is to get something moving or get something rolling. And it's analogous to mass when we have linear momentum. A big rock, massive, is a lot heavier to push and start going than a much smaller one which is less heavy. Now, it turns out that the moment of inertia for the pipe is larger than the moment of inertia for the cylinder. And so that means that in our race, it's harder to get the cylinder started. And so the cylinder ends up going down the ramp slower and losing the race. The formula for moment of inertia doesn't just depend on the mass, and it doesn't just depend on the radius. It actually depends on the mass times the radius squared. So for objects where all of the mass is concentrated on the outside, like our cylinder, we have a high moment of inertia. In fact, figure skaters and gymnasts take advantage of moment of inertia. Before a figure skater goes into a jump, they start with their arms really wide, with a large moment of inertia. As they start their spin, they bring their arms in, and they reduce their moment of inertia, and they therefore make themselves spin quicker. It's not just figure skaters. Power plants, Formula 1 cars and satellites all wouldn't work without a good understanding of moments of inertia.